Hello everyone. We have a question which says that given that tan alpha is equals to 12 upon 5 and tan theta is equals to 4 upon 3. That means we have two different angles, angle alpha and theta, and that can be seen in the diagram alpha and theta over here. The question says that show that the coplanar forces shown in the diagram are in equilibrium. Before we should understand what the coplanar forces are the forces which act at a single point. As if we look at the diagram, we can see that the 78, 50 and 112 Newton force all are acting at this particular point. That means all these three forces are coplanar forces. The question says that show that the forces are in equilibrium. So basically we have to show that the forces are in equilibrium, and for that definitely we have to split up the components, the horizontal component and vertical component. So first of all we should understand what the horizontal and vertical component are, because I have seen that most of the students have misconception and they think that the horizontal component is always a cos component and the vertical component is always a sine component. It is not like that. It depends upon where the angle is. If the angle is over here, the side next to the angle will always be a cos component and the opposite would be a sine component of this particular given force. But if the angle is over here, the side next to angle would be a cos component side and opposite would be a sine component side of this particular angle. So basically it depends upon the angle, and after that you could easily judge where to write cos and where to write sine. In the question, they have written as tan alpha and tan theta, and when we split up into forces, we need cos and sine. As you can see, I have split up this 50 and this angle theta. The horizontal component is 50 cos theta and the vertical is 50 sine theta. Similarly for 78 and this angle alpha, so this would be 78 cos alpha and 78 sine alpha. So basically we need cos and sine over here, but they have given us tan. So we would be using the right angle triangle, and by using the Pythagoras theorem we could easily work out the values of sine and cos component, and we know that tan of a particular angle is equal to opposite upon adjacent. After drawing the right angle triangle, 12 is opposite and 5 is adjacent over here, and by using the Pythagoras theorem and then solving it, we could easily get the value of this hypotenuse, which is 13. The same method goes on with the angle theta. Tan theta is equals to 4 upon 3. 4 is opposite over here, 3 is adjacent over here, and this 4 and 3, by using the Pythagoras theorem and then simplifying it, the hypotenuse would be 5, which is over here. Now because we have all the three sides, we could easily work out the sine and cos component, and sine alpha is 12 upon 13 and cos alpha is 5 upon 13. Similarly sine theta and cos theta from this particular triangle. So now we have all the values of sine alpha, cos alpha, sine theta, cos theta. Now we have to show that the forces are in equilibrium, and when we say that they are in equilibrium, that means based on the equilibrium condition the opposite forces are equal. And if we make the opposite forces as equal, so definitely the right hand side and the left hand side of the forces should be equal for both the horizontal as well as the vertical forces. So splitting up into horizontal and vertical component, so horizontal forces over here we have 50 cos theta and 78 cos alpha, both are in opposite direction. Make them equal because the equilibrium condition we have to show. So 50 cos theta and 78 cos alpha with an equal sign. We know the value of cos theta and cos alpha over here. Placing them, simplifying that, we can see 30 is equals to 30. That means horizontal forces definitely is creating a condition of equilibrium. We also have to verify the vertical forces. We can see two forces pointing upward, 50 sine theta and 78 sine alpha, and we have 112 Newton force which is pointing downward. So definitely the sum of these two would be equal to 112. So by placing the same condition, that 50 sine theta plus 78 sine alpha, which is over here, is equal to 112, 12 from here and placing the value of sine theta and sine alpha from here, and then after simplifying we can see that 112 is equals to 112. So finally we have shown that the horizontal forces are also making a condition of an equilibrium as well as the vertical. So the question was about show that the forces are in equilibrium. We have shown that.